All right, so this is going to be our third distillation and probably kind of our most difficult, right? So we're going to distill this 2-methylpentane and cyclohexane, right? And we take a look at their boiling points, they're actually relatively close, so 60.3 degrees Celsius and then 80.7 degrees Celsius. And so these are quite close. And so since they're close, a simple distillation will simply not be good enough to separate them. And so one idea to do is what's known as a fractional distillation. And so I'm just going to draw our liquid in this round bottom here. We'll have some orange liquid and some purple liquid, and then we'll say that the orange one is the low boiling point and the purple one is the high boiling point. And so what we do here is add a column. And then we collect it out of the top. And inside this column is some kind of high surface area material. Glass beads are often used. And so the idea here is once you start heating, right, these things are going to turn into vapor. But at first, because their boiling points are relatively close, their vapor pressures are going to be relatively close. And so you're going to get approximately an even mixture of your components right here. You're not going to do very much separation at all. A little bit, but not too much. And so on these high surface area column, what's going to happen is that they're going to recondense. They recondense down here on this column. And then as you continue heating, they're going to re-vaporize. And every time they re-vaporize, the lower boiling point will vaporize more than the higher boiling point. And so you'll get a purification further and further, right? So then we go even further. And as you can see, right, the low boiling point one is now starting to make up the majority of the composition. And so in theory, by the end, you have a pure substance. Or at least relatively pure, right? And so you can see the advantage here of doing this is that you only have to do one distillation. Remember when we did our second distillation, we had to redistill some stuff. Had we used some kind of fractional distillation, we may not have had to do that. And so each one of these vaporization, condensation steps is what's known as a theoretical plate. And you can see at each one of these condensation, vaporization steps, we get more and more pure material. And so the more theoretical plates that we have, the more pure the material is. And as we said, a simple distillation, which we previously did, is only one theoretical plate. And so depending on how pure you wanted your substance, how close the boiling points are, you could do things to modulate how many plates you have. And so the longer the column that you have, the more plates you have, and the more plates that you have, the better separation that you have. However, there's a big problem with this fractional distillation. And that's a lot of material gets left behind, and you need this material here in order for this column or this distillation to work. And so you don't get as good of yield as you would in a simple distillation because you have a lot of stuff left over and then a lot of stuff leaving your column, right? And so the problem here for this stuff is to do these fractional distillations, we need a lot of material. But the whole theme of our lab here is semi or micro scale, right? But we are doing micro scale, or at least semi-micro scale. Which by definition, right, is a small amount. And so this technique only really works if you have a large amount of compound. And so how are we going to solve this kind of conundrum? And so our solution here is to use a spinning vane column. And so what this is, inside of our little conical vial, we're going to have this spinning vane that has these grooves here. And this thing is obviously going to spin. And so as our vapor comes up here, right, it'll condense somewhere up here. And then when we spin, the centrifugal force is going to push our liquids back down. And so you can see how we're getting the pros of this fractional distillation without the cons of losing some material, right? And so the idea behind the spinning vane is that we get more plates without needing a longer column, which would require more material. And so that's the theory behind this. Let's check out how this lab goes. Again, we're doing a distillation, so we should get pure materials, but it's unreasonable to expect a 100% purity. All right, so the first step is going to be to set up our distillation apparatus. We've got a 5 ml conical vial here, and then we've got a little spin vane in here as well. On top of this is going to go our Hickman still, but first you have to make sure you have the cap, and then an O-ring. It's on there nice. And then you can put the still on top of here. Spinning part should balance out in the middle. Screw this on. Cap this end with a little bit of an aluminum covered cap. And then on top of here, our thermometer is going to go on top of here. So we've got our thermometer that's going to go in there. We've got this little tiny O-ring, and I've already previously checked it out, so I need to put this O-ring around 35 Celsius in order to fit on our still. Whoops. Before we put the O-ring on, you want to put this cap on here first. Then put the O-ring on. Somewhere right around there should be good. This falls down, but not past the O-ring. And then this goes into our thermometer adapter. And you screw it on. And then you can see this part already here has an O-ring there. And so this will then go into our Hickman still. Screw it on. And then all of this goes into this heating block right here. And then we add a clamp to keep it in place. Cool, that looks good to go. And then we'll just add a thermometer in here. And then clamp that in as well. But before that, we want to check and make sure that our little spin vane can freely rotate. And so if we zoom down here and turn on the rotation, we can see that it is indeed free to rotate. So off screen, I'll go ahead and add our substance in here, and then we can go ahead and get started with our distillation. All right, so ready, guys, go ahead and start distilling. You see I've put the compounds in here. They're both clear, colorless liquids, and it's still a clear, colorless liquid. So let's go ahead and turn the heat on to about, let's go with 50 for now. And we'll start slowly stirring I'll turn my stirring up to 100 rotations per minute. And you can see it's free to rotate in here. Go ahead, crank it up to 75. Let's go 85. You can see we've got really slow heating. Don't want to be here all day. We're just gonna go ahead and turn it to 115. We can see this is heating quite slowly. Just go ahead and turn it up to 140. Let's crank it up to 150. You can see we're starting to get a little bit of bubbling, probably a little premature, but I'm going to just go ahead turn this stirring to intermediate. So we're going to go at 500 RPM. Lab manual says to once the liquid enters the column, the spin rate should be increased to the maximum, but I can't really tell. if liquid is entering the column or not. So I'm just going to go ahead and crank it up to maximum right now. And our max looks like is 1150 rotations per minute. You can see some condensation starting to reach up here. So we should be starting to collect distillate somewhat soon. If we take a look down our thermometer here, you can see that it's starting to reach close to 60. So we should see some distillate coming in real soon here. Take a look now, you can see it's peaking out right about 60 degrees. All right, let's go ahead and collect some of our distillate. You can see I've labeled a vial number 1, and I've capped the lid with some more aluminum foil. At this point, you can tell we've got approximately maybe a little bit less than 800 microliters, but close enough. So we're done with fraction 1. We'll go ahead and collect about 400 microliters of fraction 2. And then that fraction 2 will be a mixture of components, so we'll just toss that one out. Our thermometer up here, by the way, is just reading like 58, 59 degrees Celsius. And since we're done collecting our first fraction, we're going to crank the heat up a bit more. I'm going to turn it up to 175. Let's go ahead and collect some more of this fraction number 2, or our first bit of fraction number 2. Got just a little bit, not very much, maybe 1 or 200 microliters. Collect just a tiny bit more for fraction 2 before we move on. We're going to turn the heat up to 200. Let's collect some more. See if we have any more. As you can see, at this point, we're collecting distillate very, very slowly. And so what that tells me, that's probably evidence that the lower boiling point one is pretty much gone. So I think all we've got left is probably that third fraction, that high boiling point one. So we're just going to go ahead, leave it be. You can see our temperature is starting to go up. Right, if you look at the thermometer, it's going up above 60, so we should start collecting our third fraction here pretty shortly. Let's just try to get rid of as much of this leftover gunk as we can, because if not, it's going to contaminate our third fraction. You can see there's no way I can really get all of it out. Second fraction probably only has like 200 or 300 microliters, but we'll call it good enough. You can see our thermometers going up in temperature nicely. Still haven't reached the boiling point of the second compound, so we still need to keep heating. But it'll keep going up. go ahead and start collecting some of our third fraction. So this is the 800 microliter example. The 800 microliter example, you can see we're still a little bit short, but we're going to call it close enough. We're almost pretty much out of liquid, so we're going to go ahead and turn off our heat, and we're going to let this just rotate. You'll see the temperature is going to start dropping soon. But we've got our first and our third fractions that we can go ahead and run our analysis on. All right, so now we've got fraction 1 right here, and so we're going to prepare our sample for the GC, and we'll actually do fraction 2 and 3 so you can see all the changes. We're going to use a different syringe for each one, that way we don't cross-contaminate. So just go ahead and open up this box. You can see in here we've got a nice syringe. And so what we're going to do is pull up about 25 microliters of the liquid, and then up to 100 with the rest being air. So let's go ahead, open up number 1. Place your syringe inside. And then pull out about 25 microliters. See, it's about 25 microliters. And then just pull up all the way to 100 for some nice air peak. All right, so we've got our sample inside of our syringe. We've got our GC here. What we're gonna do is go ahead and hold the syringe correctly. So one hand hold right here, 2 fingers right on this port here, and then your thumb right here. What you're gonna do is you're gonna stab the GC, plunge the liquid in, and then smoothly pull out. You wanna keep your thumb here because it might push back and you don't want this syringe to fly back at you. And then after that, you're going to push this little button that tells the GC to go ahead and record. So line it up, stab it in, squeeze it in, and then pull it out, and then press the button. And now you're recording.